Good afternoon, ladies and gentlemen. Dr. John Belkowitz here. Having a great morning, enjoying my coffee, watched the sunrise. Woke up at about 4:20. Got out of bed about 4:30. Sunrise was about 5:30, maybe 5:15 was when it really started peeking over the horizon. And it was just has been a beautiful morning. So pretty excited for the day. We're doing Q&A day today, and this is a question that my dad asked me. It was at the beginning of my PhD, and when he first really understood what I was doing. And if you ever have looked at my PhD, not that my expectation is, it reads like Mark Twain. That's not true. That's not true. It does not read like Mark Twain. It's 279 pages, 292 pages that focus on the impact of nanosilica size and surface area on the mitigation of ASR in concrete. Now, if you look at the title, it's a little funny. It's they forgot to put a word in the title, so it doesn't really make sense. But anyway, every perfect tapestry has its flaw. But Dad asked me, Jonathan, why do you like this stuff so much? I mean, if you think about it, I have invested a majority of my life on colloidal silica and hundreds of thousands of dollars, if not millions of dollars, on not only colloidal silica, but what it could do for concrete, for sustainability, for service life, ultimately to make that concrete stronger and last longer. And I really do believe that I am a concrete superhero. I really do believe that my job on this earth, with my team that I get to work with every single awesome day, is to save the world with all the concrete in it. And Dad's question, why nanosilica, why do I like it so much, it is very easy to me. It's the answer. And I'm not trying to sound poetic or mysterious here, but it is the answer. It's the answer to our concrete problems. There are a lot of great technologies out there. There's a lot of new and emerging concepts that are breaking ground that are just so awesome. And colloidal silica is the tip of that spear. There's a second place, there's a third place, but colloidal silica is a scalable product. It looks like an admixture, but acts like a supplementary cementitious material. It has a very high purity. It can be gotten from recycled means as well as manufactured. You can add things to it, not only modifications, but you can blend it with different additives and admixtures to increase their performance. Colloidal silica is not a lone wolf. It doesn't work on its own. It really needs other materials. And, there's wonderful work by some great universities out there that show colloidal silica has enhanced not only the thermokinetics of cement hydration, but also the efficacy of polycarboxylate high-range water reducers. And through our work, we've seen even more benefits out of other things like hydrophobic emulsions, shrinkage-reducing additives, and as I want to go into the chemicals of those things, some of that is proprietary to what we do, but colloidal silica has a way of answering the real problems that the industry feels the pains of today. Now, it's not the cheapest technology, and it's not the easiest to use. It's like when polycarboxylates first came out. There is a sticker shock. There is I've been doing this 30 years, and that's not how we've been doing it with our other admixtures. So there is a learning curve with colloidal silica, and that can't be denied. And the other thing, there is no ASTM. So recognizing all of that, recognizing the obstacles and the path of resistance to market saturation, and really the industry recognizing that, I still think that the time and the resources that we put into, Intelligent Concrete puts into colloidal silica, every day is worth it. Because I feel like I can see the future. And I feel like we can see, I've got wind turbines on the horizon. We're not going away from this renewable energy movement, and eventually coal combustion residue is going to be quality, is going to be hard to come by. Now, I think that that warrants some type of movement beforehand. I'd rather be proactive than reactive, and that's why 10 years ago, 15 years ago, however many years ago, when I first saw that presentation given by Brian Greene of the U.S. Army Corps of Engineers, I believe it was in 2005 or 2006, so we're talking 14, 15 years, or 2005, 2006, 13, 14 years, excuse me, I knew right away. I saw the impact that the colloidal silica, or as Brian called it, the ultrafine amorphous colloidal silica, which was a 3 to 100 nanometer dispersion with a 35 nanometer, mean to it, and 80 nanometer or meter squared per gram surface area with a specific gravity, I think, of 1.1 and a solids content of 25%. Really was focused on a rock matching grout, but I could see if we could tune the particle size with the hydration process and the chemistry of that cementitious package. There were so many avenues where this technology could help out concrete, and that's where I'm at today. 13, 14 years later, I'm at the point where we're starting to apply that, and other folks are starting to see it in the industry. I'm not the lone wolf anymore. Neither is this technology. It's being combined and used in ways that are just absolutely awesome. So why do I love this technology? Because I believe it is the answer to a lot of the problems that we face in the concrete industry. And I'm excited to see how it evolves and makes it through the industry. And that's the reality of it. As cool as I think the technology is, and as awesome as I know as it can be for our industry, the industry has to be able to accept it, and the industry has to want it. And if that doesn't happen, as cool as of a technology it is, we'll never see it again, or we'll see it 10 years from now. So I'm excited to talk about other awesome technologies that are out there in the industry. As you know, I love colloidal silica, and I wanted to take this time to give you a little background of why I'm so passionate about it and what it can do for concrete. So thanks for joining. Don't forget to like and subscribe. Let us know if you got any concrete questions, concrete concerns. Go concrete! Beat asphalt!